Hello everyone and welcome to another simple science video, and in this video in our IGCSE revision series we're going to be introducing an industrial application, a very important industrial application of electrolysis. So if you haven't watched the previous two videos on electrolysis which explain the basics of electrolysis of aqueous and molten solutions, I highly suggest that you do, because at the end of the second video, I had put in a cheat sheet that you could memorize and learn from, which will enable you to solve almost any electrolysis problem, probably all electrolysis problems at the IGCSE level. So in this video, I'm going to introduce an industrial application of electrolysis. It's a very important application, and it's to extract pure aluminium and to basically obtain pure aluminium from its most natural ore. Okay, so of course, due to a particular reason pertaining to reactivity, we must use electrolysis to extract aluminium. However, this process is very long. It's not as simple as just electrolysis. We have to learn about the processes prior to electrolysis, such as the preparation of the aluminium oxide ore before it is electrolyzed, as well as introducing the environmental and economic factors that come into play due to this process, and why recycling is a very good option as a result. So now let's just talk about and let's just introduce the process of extracting aluminium and the nature of this process. So we're going to be separating aluminium from its most natural ore. We're going to be separating pure aluminium from a compound. The truth is, aluminium is a very, very reactive metal on its own, so therefore it exists in the natural world as a compound. Okay, so we're going to be separating compounds, and this process aims to separate aluminium, denoted as Al, from bauxite, which can be seen as impure aluminium oxide. So bauxite is known or can be seen as impure aluminium oxide, and it basically contains a variety of hydrated aluminium oxides. So it's almost like a mixture of aluminium oxide salts. And for simplification, just look at bauxite as an ore of impure aluminium oxide. Okay, so why do we have to use electrolysis to extract aluminium? So a very, very important concept that you should know by now is the reactivity series, where the position of carbon in the reactivity series will determine whether you would have to separate with electrolysis or separate via carbon reduction for simplicity and cost efficiency matters. Okay, so aluminium, a metal, is more reactive than carbon, so therefore it must be separated by electrolysis. The method of extracting pure aluminium from the impure bauxite ore will come through four processes. So the first three processes will be the processes that will purify aluminium oxide before electrolysis. So the first step is, from the original bauxite ore, we're going to crush the bauxite ore and mix it with moderately concentrated sodium hydroxide in conditions of 140 to 240 degrees Celsius at a pressure of equal to less than 35 atmosphere. So it's quite harsh conditions. It's very high pressure conditions, and we are going to form a substance called sodium tetrahydroxoaluminate. And that is the basic equation to produce this substance. So that's the first process. So aluminum oxide reacts with sodium hydroxide in the presence of water to produce sodium tetrahydroxoaluminate. After the sodium hydroxide treatment, the sodium tetrahydroxoaluminate, it's a long word, is going to be seeded with the previously produced aluminum hydroxide. So seeding is basically a process to provide many but small surface areas for aluminum hydroxide to be produced. Okay, so the sodium tetrahydroxoaluminate will be seeded with some previously produced aluminum hydroxide to produce new aluminum hydroxide. So the process of precipitation is to produce aluminum hydroxide. Okay, so basically this process is the sodium tetrahydroxoaluminate is going to be seeded with aluminum hydroxide to produce more aluminum hydroxide, and produce a byproduct of sodium hydroxide. So after precipitation, the sodium hydroxide will be simply heated to form aluminium oxide. So that's the stuff that we are looking for to electrolyze. So we're going to obtain from formation pure aluminium hydroxide simply by heating aluminium hydroxide at a temperature of 1200 degrees Celsius. And this is simply a typical decomposition reaction. Okay, so one compound is heated to produce two compounds. So the aluminium hydroxide is heated at a very, very high temperature to produce aluminium hydroxide, pure, and water. Okay, so now we have obtained pure aluminium hydroxide. So now we go to the main process of electrolysis. So again, all these processes, you should be able to remember a particular equation that will help you very much in learning and memorizing the process, because you do have to memorize the process. Okay, so that's the basic diagram to describe the layout of the electrolysis. Okay, so aluminium oxide, the pure aluminium oxide produced from our preparation steps is going to be mixed with a substance called cryolite. And cryolite is basically a catalyst. It helps reduce the activation energy. So the cryolite, first of all, reduces the activation energy, and it also is a very important economic factor because cryolite helps reduce the melting point of aluminium oxide. So if you reduce the melting point, you are going to reduce the required operating temperatures. So you require less energy and hence less money to operate and produce aluminium. Okay, so the molten aluminium oxide at the basic fundamentals of electrolysis is going to exist as Al3 plus positive ions and oxygen 2 minus negative ions. Okay, so just like how we did in the previous video, we are now going to analyze what is going to happen at both the cathode and the anode. So first of all, at the cathode, we know that at the cathode, it is a source of electrons. It is where reduction will occur. It is where positive ions will gain electrons from the source of electrons to reduce itself to a neutral state. So the positive ion in our mixture is the aluminium 3 plus ion, and it will gain, so two aluminium 3 plus ions will gain 6 electrons in total to be reduced to 2 aluminium atoms. Okay, so 2 aluminium atoms in the electrolysis mixture produced from the reduction at the cathode will come out as molten aluminium. So that is the main product that we want. Now at the cathode, the O2 minus ions or the oxygen 2 minus ions will be oxidized. At the cathode, we will give up the negative charge. So proportionally, 2 O2 minus ions will lose 2 electrons to form a diatomic molecule of oxygen gas. So at the anode, oxygen gas will be produced. However, interestingly enough, at the operating conditions at the cathode, where it is very hot and possibly at a very high pressure, the oxygen gas will immediately react with the carbon of the anode to produce carbon dioxide. So a byproduct of this process in total is carbon dioxide. Okay, so as a result of the oxygen reacting with the carbon anodes, the carbon anode will wear away and they will have to be continually replaced. So that is the processes, the main processes that you will need to learn for the entire process of extracting aluminium. So now let's just quickly discuss the economic and environmental considerations. So first thing to consider is the huge amount of electricity required for this process, because first of all, aluminium has a very high charge for electrolysis. It is a 3 plus positive ion of positive aluminium ion, and the operating conditions for this process is 1000 degrees Celsius in temperature. So therefore, you will require a very, very high current to drive this process. Basically, a high current correlates to, according to the I²R laws, to a higher temperature. So you must require a very high current in your anode and cathode to generate this high operating temperature conditions. So therefore, you will require a large amount of energy. In addition, there is going to be large amount of energy and material costs to, as I said, the anodes will wear away because it reacts with oxygen. So therefore, we will have to spend a lot of energy and material to produce and replace these anodes, and also to produce the cryolites that will be used in the mixture for electrolysis. Environmentally, there will be pollution, of course, noise pollution due to the processes and the preparation for these processes, and of course air pollution because carbon dioxide is a byproduct of this process. In addition, there is going to be loss of landscape like pretty much any other large industrial manufacturing processes. And due to the mining processes and the actual electrolysis itself, you have to create the facilities and the transporting of the materials, since this is a very, very large process. So as a result, to mitigate all of these issues, we must recycle aluminium. Okay? So that's it. Now, for all of the processes that you need to learn for the extraction of aluminium, you can associate one equation for each of the process. So for the first three processes to prepare the aluminium oxide for electrolysis, so for the first equation is the equation of formation, equation number 2 is the equation of precipitation, and number 3 is the equation of the formation of the pure aluminium oxide. Okay, and these are the main equations of the electrolysis itself. I would consider these three equations as the most important equations for this topic, and that pretty much wraps up my video on the extraction of aluminium. This is an example of electrolysis, and yeah, I wish you all good luck in your revision, and I hope to see you soon.